Hello class, in lesson 6.1 special right triangles, we're going to look at the special right triangle of a 45-45-90 ratio and use that to find the length of the hypotenuse or the legs on the right triangle. Now let's look at the ratio between the angles. Now on a 45-45-90 degree angle, this is an isosceles right triangle, which means that the two legs are going to be congruent. So whatever measurement this leg is going to be the exact same measurement. So if the length is equal to 1, the other leg is also equal to 1. The hypotenuse, because this is a 45-45-90 degree triangle, the hypotenuse is going to equal to the measurement of our leg times the square root of 2. So the hypotenuse is always going to equal to the measurement of our leg multiplied by the square root of 2, which means we can figure out the hypotenuse and the leg using any of the other sides by doing one of two things. Since the legs are going to be the same, obviously we just have to copy that number. But if I want to figure out the hypotenuse, this length right here, which is the side opposite of 90 degree angle, all I have to do is get whatever this number is and multiply it by the square root of 2. And to go backwards, if I want to figure out the leg knowing the hypotenuse, so if I know this and I want to figure this out, all I have to do is divide, go in the opposite direction, and divide by the square root of 2. So that's how we're going to figure out the side on this special ratio, on this special right triangle. So let's look at an example of this, okay? So let me just draw this triangle right here, where it's n, and the n times the square root of 2. So look at this example right here. Notice that the hypotenuse, again, is the side that's on the opposite of the 90 degree angle. This measurement of B is going to be whatever the leg is times the square root of 2. And the two legs, well, because this side here is 8, that means that the other leg is also going to equal to 8. So here, the value of A is going to equal to 8. And the way we're going to figure out the hypotenuse, this measurement here, from here to here, is to simply multiply this leg of 8 times the square root of 2. So 8 times the square root of 2. And in this situation, we cannot simplify since the 8 is on the outside of the radical and 2 is on the inside. It can be simplified. So the value of B is 8 times the square root of 2. So here are the two solutions for A and B. Let's move on to example number 2. Similarly, like in example number 2, again, let me just write my ratio. I'll draw my triangle here. N, here's my 90 degree angle, and the hypotenuse would be whatever n is times the square root of 2. I'm going to do the exact same thing. Since this leg is equal to 25, that means that this leg is also going to equal to 25. So the value of K is equal to 25. To figure out the measurement of the hypotenuse, this measurement right here, I'm simply going to get the value of 25. That's the measurement of the leg. This measurement of n, which is 25, and multiply it by the square root of 2. So 25 times the square root of 2. And because I can simplify, that's our answer for m. M is equal to the square root of 25 times the square root of 2, or 25 radical 2. So there's your answer. So let's look now at a different example. Now at number 3. Now in number 3, they're not giving us the legs. We want to find the measurement of the leg. So this time, they're giving us this length right there, the hypotenuse, and I want to figure out the measurement of the two legs. So this time I'm just going to simply go work backwards, since figuring out the hypotenuse multiplies the leg by the square root of 2 to go backwards, and to get the legs given the hypotenuse and to figure out the length of the legs, I'm going to work backwards and divide by the square root of 2. So if I get 5 divided radical 2 and I divide it by the square root of 2 by radical 2, I can see that the two radicals cancel each other out. Radical 2 divided by radical 2 is going to equal to 1, and the only thing we're going to be left with is going to be the value of 5. So that means that this leg is equal to 5, and because the other leg is going to be identical, that's also equal to 5. So the value of u and v both equal to 5. So this is the answer. So you see, you're only doing one of two things. You're either going to multiply by the square root of 2 to get the hypotenuse, or if they give you the hypotenuse, you figure out the legs by dividing by the square root of 2. So like in this example, same situation. Notice that they're giving us the hypotenuse across the 90-degree angle. That's the hypotenuse. So we're going to figure out the legs by getting this hypotenuse and dividing it by the square root of 2. And just like before, these two things cancel each other out, leaving us only with 9. So the two legs measure 9. So E and F both measure 9 units. So let's do another example where they give us the leg. Here it's going to be a different number, the square root of 10. So here they're giving us the leg. That means that this leg R is also going to measure the square root of 10. And the way we're going to figure out the hypotenuse is by multiplying. So we're going to get the square root of 10 and multiply it by the square root of 2. In this situation, this multiplies to the square root of 20. Since both numbers are inside the radical, the way that you multiply this type of situation is that you multiply those two numbers together. We didn't do that on examples number 2 and on example number 1 because we were multiplying the 25 that's on the outside of the square root with the 2 that's on the inside. So those can't be multiplied together. However, on this example, because both numbers are inside the square root, now they could be multiplied together. And as a result, this simplifies to 5 times the square root of 2. And the way we simplify that, let me just review how to do that. We break this up into its prime factorizations. So 10 times 2 is equal to 20, which can be broken up to 5 times 2. So this is equal to multiplying 1 5 and 2 2's. And because of what the square root does, it eliminates the pairs of the values that we have. Since we have a pair of 2's, we can write that pair of 2 on the outside and then the 5 on the inside. So that's how we simplify to that. Let's look at example number 6. So for example number 6, notice that they give us the hypotenuse. So we know that the two legs are going to be congruent. So we know that H and G are going to equal to the same thing. And because the hypotenuse is 19, we still do the same strategy. All I have to do is get 19 and divide it by the square root of 2. Here, the way that we do this is by rationalizing our denominator. So we would have to multiply by the square root of 2. And since 19 and 2 are not both inside or outside, that's going to be written as 19 in radical 2. And on the bottom, the two radicals are going to cancel each other out. Notice that I'm going to have a radical and a pair of 2's, which is just going to give me 2. And 19 divided by 2, that's equal to 9.5. And then radical 2. And the shortcut of getting this same answer right here without having to do all of this work, look at what happens. In these type of situations, since both of these numbers are not in the radical, the shortcut to get this answer here is to simply divide 19 by 2, which is 9.5, and then multiply it with the square root of 2. So in a situation like this, you don't have to do all of this. You can just simply do this shortcut to get this answer a lot quicker. So divide this by this number inside, but you just have to add that radical 2 on the side. That's essentially what's going on in these type of examples. So this is your answer. 9, not 19, 9. I don't know why I keep writing 19, 9. This should be 9.5, which is the same thing as 19 over 2. So for example number 7, again, we're looking for the two legs. And they're providing the hypotenuse. They're telling us that the hypotenuse is this value there. So to figure out the two legs, we're going to get the hypotenuse and divide it by the square root of 2. Now, here, because we have two possible values, we have the 2 and the radical 14, these two numbers are inside the square root. So the fastest way of doing this is to simplify the two radicals. This is equivalent, let me highlight this. This is equivalent as basically having this 2 on the outside, and on the inside of the square root having 14 divided by 2, which reduces to 7. So in this type of situation, if you do have a radical, if you're dividing by the square root of 2, and that number is also inside the radical, then you can divide those two numbers inside the square root and leave it as just this value there. The outside number doesn't happen, nothing happens to that, so that stays on the outside. And there, that concludes our notes on the special right triangle of a 45, 45, 90 special right triangle and how we find the legs or the hypotenuse given one or the other. If you do have any questions, do not hesitate to send me a message through Remind or email. And I hope, again, this lesson was easy to understand. Thank you again for watching, and I hope you have a great day.